All right, we're back in business. I hope this works now. All right, I'm going to talk about this today. I did not change the title back to what it was shown on your brochure. But yeah, I'm going to talk about Tanuki today. Tanuki is a side project that I built. And I've been doing this for quite a while, actually. So this is just the latest incarnation. You see some of these cute icons here. I have them in stickers. So if you come to me after the talk, and I'll be here the whole day, right? During the break and so on, I'll give you guys some stickers. I just put this in like just 5 minutes ago to really talk about myself because I realized I didn't have anything to talk about myself before this. So this is me. My name is Sau Sheong. I'm from Singapore. Right? Anyone from Singapore here? No one? Okay. I feel very alone now. So I've been doing software development for a long time, 25 years now. I think I'm probably the oldest guy in the room if I do a quick scan. Right? So, okay, never mind. I do a lot of tech conferences. I speak in tech conferences. I actually run this thing called the GopherCon Singapore. Did this for the past 3 years. So if anyone of you have been in Singapore for, during GopherCon, I have stickers as well for that, but they are actually at the registration counter downstairs. I'm not sure whether they ran out or not, but if they ran out, sorry, I don't have any more. Okay. I also wrote programming books. I wrote a Go programming book called Go Web Programming. So that's a little bit dated now. It's 2016. Today is 2019. But before that, I wrote like 3 Ruby books. So that's one of the reasons why you see there's actually a bit of a Ruby reference here today. I was a Rubyist for about 10 years. I work in this company now called SB Digital. We started this company, this is a subsidiary of Singapore Power. Singapore Power is the main utility company in Singapore. Basically, what we do is we deliver electricity from the generation companies all the way down to the homes, right? We started off this team called SB Digital some time back. Now we are a full-fledged company, and we are selling our solutions and software to different companies. Previously, I used to work for PayPal, HP, and Yahoo. Yahoo is kind of interesting because the last time I came to Ho Chi Minh City was 11 years ago, and in 2008. That was before Go was started. And I'm back here 11 years later, right? Ho Chi Minh City has completely changed, at least to me. Okay, let me start into the talk. So I assume all of you guys are software developers here in this room. Anyone who do not develop software at all? Like you're just here for the festivities and for the food. You know? So everyone is a software developer. So you know software is always changing, right? And requirements change, right? So anyone disagree with me? No? Okay, it's a tough crowd. Libraries change as well. So you see all the time that people upgrade their libraries, whether it be open source or even commercial. Libraries change all the time. And of course, programming languages change, right? Just as I mentioned, 11 years ago, Go didn't exist. Today, Go exists. Change. You heard just now that before 2014, Go wasn't really that popular in Vietnam. Now Go is apparently pretty popular here. I see this crowd here. And there will be new languages coming out. There will be new things coming out. So things evolve and things change all the time, right? So about 10 years ago, I was mostly doing Ruby. About 10 years before that, I was mostly doing Java. So things change, things evolve all the time. So finally, people change too, right? So today you might be writing this code and you think you're going to be in this company forever, or you're going to think you're going to do this thing forever, but no, unfortunately, things do not happen this way. Tomorrow, you might leave to a different company, or you might join, and the guy who was working on the code previously, he leaves. So all of these things change all the time. So what do you get normally? Right? So you get dependency hell. So this happens really, really often. And unfortunately, it's one of those things that we get so used to sometimes that we don't really think too much about it, right? So, okay, thing changed. Guess what? Let's rewrite the whole damn thing from ground up, okay? And then another guy comes in, or library changes, or programming language to say, okay, man, let's throw away the old stuff, let's redo all these things again in this new programming language, or using this new library, or using this framework. So this is something that we get used to sometimes, but and that gives us a very bad reputation in the software industry because you are the guys who throw things away and rebuild again from scratch, right? So it gets so bad that sometimes people don't really think about it. This is GitHub upgrading from Rails 3.2 to Rails 5.2. Anyone from GitHub here? Okay, good. Guess how long it took them? Any guesses? Anyone actually read this blog post? If you read this blog post, you know I deliberately hit the number that I put down here. No guesses? No one would really want to guess at all? Okay, so they took them 1.5 years to migrate. And after the migration, they actually celebrated it. I mean, fair enough, it's a pretty complex framework. But imagine, right, it's not even upgrading features, right? You're just upgrading the base. You're upgrading the framework. And it took them 1.5 years. And after that, they threw a party and celebrated. Okay, it was hard work, no doubt, but I mean, I'm just trying to show that how much it is within ourselves to think that, yeah, this is normal. And it's so much normal that some people like say, okay, it's okay. You know, it's inevitable, and that's okay. It's a bit like the Stockholm syndrome. Like, so you get so much used to it that it becomes okay. What I'm trying to say is that it doesn't necessarily have to work this way. There are ways of actually changing things. And there are solutions as well that actually do this already today. So one of the most obvious thing to do is really you just want to remove the dependency between blocks of execution, right? You just want to not let certain blocks be dependent to other blocks, okay? And this is not something new. This is something already very popular in the industry. You guys probably do this every day, day in, day out. You just didn't realize that you could actually apply the same thing to other parts of it you do. So any guesses where else you see this?
You can hang up your mic.
Sorry?
Yeah, like this.
Oh, you can't hear me. Sorry. So do I need to repeat myself from the beginning? No, it's okay. Okay. Sorry. Wow. Okay. Any guesses where else you would see this? No? So it's something that's very obvious, right? You guys use it all the time, right? Microservices. Basically, you're removing blocks of dependency between blocks of execution, right? Dependency between blocks of execution. And of course, Docker as well. That's really, really typical. You will see this all the time in Docker, right? So much so that basically Docker is nothing else but really removing dependency from blocks of execution. So, but that's really about entire systems, right? The whole block of it. What about web applications? What about specific, or what about a single web application? So within an application, how do you remove dependency? How do you actually not have one part of the application dependent on another? Today, most of your web applications are really just one block of execution. If you change it into Docker, you put it into Docker, you're putting the entire application into Docker. So it doesn't really solve the problem. To do that, let me go back into a little bit of the basics. So this could be a bit boring for you, but bear with me. What I'm trying to do here is really just go back to basics and try to explain how the whole concept comes about. So if you look at software application, right? Software application being the definition of a piece of software that a user uses. So how does this work normally? A user would send in a request to an application, and you get a response. right? That's straightforward, not controversial. Not controversial either for web applications because it's exactly how you use it. Application, you send in a request, you get a response. So let's look at the anatomy of a request. Request is really an action on an object with certain modifiers. And these modifiers are usually optional. Sometimes, of course, there are certain things that you need to add to it. But if you look at HTTP, how does it translate to? Basically, you're talking about a method on a URL with optional body and headers. So method are, your gets and your posts, your put and your deletes. And URL is basically the URL. The body is the main body of your content, and then a whole bunch of headers. And the response is not controversial either. Basically, you return the status. That's your 200 OK, that's your 404 not found, and so on, headers and bodies. Right, so that's the request and response. And let's look at the web application. Web applications are actually quite simple and straightforward. And most of the time, this is what you will see. You see a router, okay? And the router will pass on to handlers. So since you guys are all Go developers, or at least aspiring Go developers, some of you, this is no stranger to you, right? So you have a router, and then you pass on to a whole bunch of handlers. That's how you write using your standard library today. But that's not always what it has been, right? So in the earlier days of web application development, you have routers that will hand off to handlers, and the router is really your web server, right? So you have things like CGI, fast CGI, the Apache mods, and so on. Anyone here use CGI before? Okay. Other than Ken, nobody used CGI. So fast CGI, obviously. Apache mods. Anyone develop Apache mods before? No, Ken again. Oh, okay, another guy. Okay, great. So this is a very common model, but it is not so common nowadays. It used to be pretty common in the past. What is a lot more common nowadays is this particular model, right? The application server model, where instead of having the handlers outside completely, and you, okay, so I forgot about this, talk about this. CGI here, the handlers are actually separate and outside the main web server, and you pass information through environment variables. These environment variables basically is CGI, right? The common gateway interface. But the more common model now, today, is the model of application servers. And you have application servers from Java, .NET, but you can also get things like Ruby, for example. So if you're a Ruby developer, you sometimes might not really realize it, but very often you deploy to a Ruby application server. And there's also a very common practice in other programming languages like Python and PHP, right? So if you guys like done Zen before, for example, right? So that's a PHP application server, and so on. So this is a very, very common model. It's a very common model in enterprises as well. So for those of you who do Java, right? So this is like practically your default model. There probably aren't any other production level kind of models. .NET as well, right? You use the .NET framework. This is really the model they use. But it comes back to the same thing. Because your application server is the one single environment, it's deployed as a single block. All your handlers run within that block. So you can't really separate the dependency between the execution. What about if you develop then handlers in different languages under different environments? Right? So this is the Tanuki model that I'm looking at. If you, say, create handlers in different languages, in different environments, and then you deploy them, you could achieve total dependency of execution. And again, as I said, this is really the Tanuki model. And that's what I'm trying to do. And this is what I'm trying to explain to you today. Okay? So what are Tanuki handlers? So there are 3 types of Tanuki handlers today that I support. The first is the simplest, is a binary or a executable script. Right? I call them bins. just like CGI bins, if you get the reference. The other one is a local listener. This is nothing more than a TCP socket server that you run within the same environment or within the same machine, but under different environment, and you communicate using socket servers. And the last is a remote listener. So remote listener literally means that you're going to run this off a different server, right? You could pack this under a different Docker and deploy it somewhere else, and then you call it, right? So these are the three different modes. For bins, it's the simplest. What happens is that Tanuki will actually call your binaries executable script. You will run it. You will send a request in form of JSON, and then you will get a response also in the form of JSON, right? So pretty straightforward. And for those of you, or rather that one person here who actually done CGI before, you notice this is very similar to CGI. The main difference, obviously, is that in CGI, you actually communicate through environment variables, whereas here, I'm calling the request as a calling argument, and then what I get is the standard out, right? So standard out returns the response. For listener, as I mentioned earlier on, the Tanuki listeners are TCP socket servers, and the local listeners are started by Tanuki. So Tanuki will actually execute it. It runs up as a server at a particular port that Tanuki calls it. So you need to actually allow Tanuki to start it up at a particular port. And then it gets this you can send in a request and the response as JSON as well. Okay, so you hear a lot about the request JSON, but it's literally it's just JSON, right? So it's a JSON representation of a HTTP request. Okay, so it might look familiar to you, it might not, but generally it's just JSON with a lot of data in your HTTP request. Okay, technically speaking, you can just totally ignore this. You can take this, just dump it, and just return whatever you want to return. But obviously, if you want to interact with the user, you normally will want to pass it and then do something with it before returning it. The response JSON is very simple. It just has three things, as I mentioned earlier on. The first is the status, the second is the header, and the third is the body, right? And you need to have something in each one of them, even if it's empty. Right? It could be an empty string, but you need to have something. So let's look at a Ruby bin. This is the simplest form, okay? So you see this is a Ruby script, very simple. You can just require JSON here. Obviously, JSON is nothing much more than a string, right? So you don't actually need to use the JSON library. You could literally just pass string, and that's the whole point. The whole point is that this is the simplest way possible to actually write Tanuki handlers. Okay, sorry. So here, the first line here, after the require, you are passing the argument. The argument is literally your JSON, and then you send in a response, right? So I take the response and send it back. I put a put string, and it goes back out. Okay, the Go version, it's exactly the same, except that you do it in Go, right? A little bit more complex. Here I added some headers. And so sometimes you say, look, if it's so simple, then how do I maintain persistence from connection to connection? You literally just do it with cookies like everybody else does. Except that most of the time in frameworks, the framework does it for you. Here, you have to handle cookies yourself. Okay. And Python, this is a listener. Okay, the listener, it's you start up a socket server, you wait for data, okay, and then you return. Same principle, no different. And I will actually do a live demo now. Okay, just give me a second. Let's exit here. Okay, let me just show you the code, which is not coming up. Okay, let me give me a second. Okay, here we go. All right, so this is the Hello Ruby I showed just now. Okay, let me show you the Tanuki as I start it up. Okay. Yeah. So Tanuki start. Wait. So this starts up Tanuki. So it starts up as a server. Right? You can change the port number. You can do a number of other configurations, but this basically sets up the most simple Tanuki server. Let me do this. So bring it over here. Voila, error. Sorry. Yeah, so let me give this a go again. I do not understand why there's an error. It's probably because I should do testing before that, but never mind, let me try a different one. Right, anyway, so obviously that was the other one that I did not try. I will not try to debug it here. Let me go to the code here. Right, so you see this is a form. This is form Ruby. Oh, by the way, this again, sorry, I forgot to explain on this part here. So how do you define the handlers? The definition of handlers is in this YAML file called handlers.yaml, where you say what kind of method it is, where it should route to, what kind of handler it is, and the path, the physical path to the handler itself. So here, if you look at this guy here, let's go down a little bit. From Ruby is a bin. It goes to this route, and this is the handler. This is the code that it should be executing if I do a get, right? So very simply, here it responds this way, and I could choose, right? If it's a get, I do it a certain way. If it is a post, I do it a different way. So if it's a get, basically I do this little neat Ruby trick, which is I take whatever is after n. I use this as a simple HTML, and I return it. So get, it returns data.read here. And let me try to enter something here. Let's say GopherCon Vietnam. Am I typing correctly? Okay. 2019. And password does nothing, right? So yeah, so it returns this. And why does it return that? It's basically when I do a post, it will just say return hello, whatever that uname is. Uname is basically this guy here, uname, right? So basically it takes that and it just returns it. Okay, so this is a very simple example in Ruby. Let me show you some others as well. Basically, this is whatever is on the GitHub site. So if you go in here, you'll be able to see all of these handlers. This is the Ruby version. This is the PHP version, if you're interested in PHP. This is the Python listener, which I showed you just now. There's a Ruby listener as well. So it just starts a server as a thread. I have it in Rust as well. So this is the Rust version. Right, it just returns this. I even have it, it's probably something that you do not want to do in normal life. It's a version in Bash. So I actually wrote a handler in Bash just to show that, yes, it can be done. Not something that you normally want to do. JQ here is actually a piece of command line software that translates JSON, right? So it actually retrieves the JSON for me, and I just carry it out, right? So it's a Bash script. So this really is the most basic form of Tanuki. Here, I also show like, hey, I run this form, it's about 180 milliseconds. let's try a different one. Let's see. I forgot this is actually not the normal laptop I use to run, so it might not have everything. Let me try. Hello. I think I understand why. Yeah, Python. I apologize because this is not my normal laptop that I use. I brought this because it's the smallest laptop I have. So I actually don't have Python and Ruby installed. So, and I think that's the reason why it doesn't run. Let me try the Go one. So let's see. I think I have it as an executable, so it should work. So this is the Go version. And you will see, yeah, the Go version runs a lot faster, right? But this is still the binary. So let me try to run the listener version. So this is the listener version. If it runs, it's very hard to type this way. Okay. So it does the same thing as well. But you see that it runs in 800 or so microseconds. So listener is definitely a lot faster because it's pre-started. And it's just a socket server. I call it, send it some data, it comes back. Right? So it's a very quick intro of Tanuki. There are a lot more things that I built inside it. There are testing tools. There are there's a lot of documentation that's available on GitHub. So please feel free to go in and explore a little bit on that. If you think that's something that's useful, please try it out. If you think that's something that you want to contribute to, please send in pull requests. Welcome all kinds of pull requests. And of course, if you want stickers, please come to me after my talk. So thank you very much.